Good afternoon. My name is Joseph Feiman. I am Chief Innovation Officer of Veracode, where I'm responsible for designing products that will bring us to the new generation of application security, as well as I'm working on the projects that would help to bring application security visibility to new height. I joined Veracode at the end of 2015, and before that I was a research VP at Gartner Fellow, and Gartner Lead Analyst in Application Security. So since 2005, I've been designing and outlining space for application security, defining markets, giving names to these markets, such as all these markets that I gave name, static application security testing, or SAST, in 2006, dynamic application security testing, or DAST, that was the same 2006 or 7. In 2008, I gave a name to software composition analysis market, interactive application security testing around 2010 or 11, and in 2012, I envisioned, defined, and gave a name to a new market, runtime application self-protection, or RASP. Part of my job was building magic quadrants, where I positioned vendors in application security space as leaders, challengers, niche players, and visionaries. And another interesting job as a lead analyst was to design hype cycles, curves that show maturity, futuristic vision of maturity in application security space. So no wonder that I come here with a presentation about application security future in the era of DevSecOps. It is obvious that DevOps should be done securely. It is obvious that security should be injected into DevOps and make it DevSecOps. It is all obvious. The problem is, it hasn't happened. It has not happened. The paradigm of DevSecOps is very popular, and yet it's very poorly adopted. Everybody speaks of DevSecOps, and very few can really show examples of deep and broad implementation. Let us take a look at Gartner hype cycle. Are you familiar with the hype cycle? Yeah, it's a curve that shows maturities of technology, in this case, in application security area. And on the left-hand side of, this is the left-hand side for you. On this side, on the left-hand side for you, you'll see dots representing markets that are poorly adopted and immature. And on your right-hand side, you see markets that are fully mature and broadly adopted. And among those markets, you'll find your well-known SAST, static application security testing, and DAST, dynamic application security testing, and web application firewall, and security information and event management, or SIEM. You'll find data tokenization. You will not find DevSecOps. It is sitting in a very, very different area. I draw an arrow to point to position where DevSecOps is sitting. You can see the area on the right, where all those mature technologies are sitting, is called plateau of productivity. Plateau of productivity. The area where DevSecOps is sitting is called trough of disillusionment. Trough of disillusionment. That's what it is. So the question is, why DevSecOps is a disillusionment and very, very slowly trying to get out of it. And I suggest to start this investigation and find out why DevSecOps is a disillusionment, why is it poorly adopted, and find ways to pull it out of trough and into plateau of productivity. It makes sense to start that investigation with a definition of DevSecOps or with description of DevSecOps. And whenever we talk with security professionals, with DevOps professionals, when we read all different white papers and articles, we read, we hear that DevSecOps, and DevOps, by the way, is all about culture. That culture makes DevOps and DevSecOps. Culture, and of course, people and processes and organizations, and some people would add templates and recipes. And when I look at that list, I feel really uncomfortable. There's something strange about that list. Something critical is missing from that list. And that critical is technology. Where is DevSecOps technology? How come that in our minds, we're not associating DevSecOps with a particular technology or technologies as we do with all other markets? Don't we need a technology or technology specifically designed for DevSecOps to make it DevSecOps? Let's compare with other markets. You know this one, market called web application firewalls, and it has its own technologies. And of course, they're called web application firewalls, and you can touch them, you can see them, you can run them. SIEM, another very famous technology. It does have its own technologies. It has data repository, it has data feeders, it has analytical tools. You can touch, you can run them, you can see them. Tokenization market. It has its tokenization servers. Static and dynamic testing. They have their static and dynamic tools. And only DevSecOps has nothing. Nothing associated with the DevSecOps. Nothing specifically designed for it. Sometimes, though, I hear claims that actually you can take any existing security technology, throw it into DevOps, and you get DevSecOps. And I don't believe it. It cannot be true. Had it been true, by today, DevSecOps would have been fully mature technology, broadly adopted, sitting at plateau of productivity, not in the trough of disillusionment where it's sitting today. So, one of the problems that we have to resolve today is to define criteria for technologies specially designed to really fit DevSecOps. And I would claim that technologies, security that might fit and will fit DevSecOps is the technologies that Dev and Ops people don't have to learn, don't have to see, and don't have to run. That is the main condition when DevOps will adopt security, when they don't need to see, learn, or run that technology. Let us take a look at DevOps objectives. Their primary objective is to deliver functionality, not even quality. Functionality comes first. Then it's probably quality, somewhere later performance. Security, clearly, security is not the primary goal for these Dev and Ops people. And we cannot require them to run complex, sophisticated security technologies in app space, such as static testing or dynamic testing, or web application firewalls, God forbid. So my point is that we need security that would not distract Dev and Ops people from doing DevOps. That's the main requirement. And I'll draw an analogy with electricity. In this room, if you want to light this room, you simply turn the switch. You don't need to learn the theory of electricity. You don't need to see electrons running down the electric current. And you don't need to run that current. You simply turn the switch. This is transparency. And that's the primary criteria for DevSecOps, for security that will work for it. And here we're dealing with a second myth in DevSecOps. The first one was that DevSecOps is all about culture. No, it's not true. To a huge degree, it's about technology, but not about any technology. It's about very specific technology, and we're now outlining criteria for these specific technologies. The first one, well, we already defined it. Transparency. Security technologies should be transparent to dev and ops people. Please do not misunderstand me. It is highly desirable for dev and ops people to learn and apply best security programming, deployment, and operation practices. But we must not request them to run this heavy, sophisticated machinery of application security technologies such as detection, testing, and protection technologies. That should be done transparently. The second requirement, incremental. Today, in testing, for example, we typically test our application at the very end of the life cycle and detect vulnerabilities. Honestly, it's way too late to go back and reprogram, reanalyze, retest your application for quality and for security to fix the vulnerability. No, testing should be incremental, and tiniest increments of the code should be able to be tested. You wrote 5 lines of code, you should be able to test it. You should be able to test the smallest pieces of code, small pieces of code, bigger, biggest, and up to the fully complete application. And you should be doing it continuously throughout the entire life cycle, not occasionally, once a while before deployment. And of course, next criterion is speed. You have to do it very quickly. DevOps delivers multiple releases every day. Security testing would take several days sometimes to test one single application. So what is required? The response time for these technologies should be measured in seconds, maybe minutes, but not in many hours or days. So now we have all these 4 criteria: transparency, incremental, continuous, and rapid. So now, applying this criteria, let us try to find technologies on the market that meet this criteria, and then we know that we found our specially designed technology that will make DevSecOps. There are 2 sources for these technologies that would meet requirements. One source is technologies that have been specially designed. Well, I would say with DevSecOps in mind. The other source is technologies that have existed for many and many years, but due to the innovation thinking of some market innovators, some vendors, they transformed traditional technologies into new ones. And we'll start with such a technology. You all know this technology. It's called SAST, or Static Application Security Testing. I defined it first time, gave it name, I believe, in 2006. So it's about 12 years old technology. And it's typically used at the very end of the life cycle when it's pretty much too late. But market innovators, market leaders have transformed technology in such a way that it offers now several variations designed for DevOps. And the first one is developer test. That's how it works. It's a plugin into your own ID. Transparently and automatically, upon your finishing programming 4 lines of code, it invokes invisible cloud request service. So it's completely transparent. You don't need to learn testing technology. It's done in the cloud and from cloud for you. And it is incremental because it will test any single increment. You've written a few lines of code, you saved. Upon save, the invocation goes into the cloud, it's get tested. And you do it very rapidly because increments are so small. How long does it take you to compile that piece of code? A second? In about 2 seconds, you receive a result from security testing. So you can do it continuously and continuously, class after class, snippet after snippet. And when it's done, you receive results immediately, and they come not to central repository, they come to you. You see results immediately. In a matter of seconds, maybe you'll fix vulnerability, you submit a request, 2 seconds later, you receive response. You know there's no more vulnerability. And only then you commit your code to a central repository. That's how it works. Developer says. I gave it just generic name, developer says. And then you continue in the middle of the development environment with a team says, another variation of DevSecOps enables static analysis. And here, while your individual developers invoke out of their IDEs developer static analysis and create their own components, and then they deploy, they commit it to repository. In repository, they're building build, and when build is ready, this team test runs and delivers rapid results. And when you do it dozens and dozens and hundreds of times, then you come to the very end of your life cycle, and you then apply your system test, your old good traditional static analysis, and you run it once in life cycle, or maybe a couple times. It is a traditional test. Yes, it runs longer. It runs maybe several hours, although our research tells us that for about 2/3 of all applications, the test time will be within 1 hour, which is not bad. Especially remember that you do it just a couple times through the life cycle. An example, the real life example I can give you, with a client, they ran team test and developer test about 800 times. 800 times through the life cycle, and at the very end, they tested 7 times with a traditional static analysis. So you see an example of a technology, an old, good, traditional one, that in order to respond to demands of DevSecOps, transformed itself in 3 variations. And these 3 variations are actually making DevSecOps enable static analysis. Now, let us jump to a technology that has been built with DevSecOps in mind. Technology is called RASP. Honestly, when I envisioned this technology and described and defined it in April of 2012, I never thought of DevSecOps. I believe there was no DevSecOps at that time. I simply believe that that technology is necessary. But some years later, by 2017, it's pretty clear that RASP is a perfect fit for DevSecOps. Are you familiar with RASP? Not many. RASP is an agent that instruments your runtime environment. It becomes an integral part of your Java virtual machine, of your .NET CLR. And because it's an integral part of the virtual machine, it has a complete view of your logic and data flow. It can distinguish between the benign access and an attack. And when it sees an attack, having the most complete information, it stops an attack one way or another. So why RASP is so good for DevSecOps? First of all, it follows these principles. Don't see, don't learn, don't run. There is nothing to see in RASP. You don't see Java virtual machine or .NET CLR as a program. It is somewhere in the server running. Same way, you don't see RASP. It's a part of your JVM. You don't need to learn RASP because there is nothing there to learn. You're not learning garbage collector in your JVM. So why would you learn this technology? There is no need to run requests for RASP because there are no requests. RASP is running always continuously without interruption. There's no need to run because it's run always 24/7. The response time is absolutely minimal, and it offers higher accuracy because it has complete insight into application. What is also good about it, it offers a new paradigm, which is application self-protection. We never had a technology before that enables application to protect itself. There is no firewall around it. It simply protects application. The only challenge for this technology is its immaturity. I would say it would take another 5 years for this technology to mature. And RASP is good not only for protection and diagnostics and monitoring, it is also very good for security testing. So let us move to the left, to the test time when your application that you're testing is up and running. And you can apply RASP there as well. So once again, it's the very same server, very same agent, that instruments environment. It has complete insight into the application. The problem is that there's no hacker anymore. Hacker doesn't exist at test time. So instead of a hacker, you should have a simulator. And that simulator comes in typically 3 flavors. It's either traditional dynamic testing, or it is embedded inducer, or it is no inducer whatsoever. I mean that just the quality assurance or user acceptance test would initiate the process of analysis. And that's how it detects vulnerability. Why I asked good for DevSecOps? First of all, it has high accuracy because it has complete insight into application internals. It offers minimal human involvement. There's no need to run agents. Okay? Inducer is automated. Agent is always running. Latency is minimal. It always next to developer. You deploy your application on the server, and server runs ISO application test itself. So once again, we're coming to a paradigm when application for the first time tests itself whenever you run it on a server. And now we can put all these technologies together along life cycle, and we'll put developer SAST for developers and the team SAST for builds and traditional SAST for complete testing. We'll use great technology, software composition analysis, to find vulnerabilities in third-party components. We'll use IAST and DAST for testing at runtime, either separately, or we can use DAST as an inducer for IAST technology, and we'll use RASP for operation. And now we can automate all these technologies. But before we do it, I want to dispel the third myth that exists here. So the first one was that DevSecOps is all about culture, which is not true. It is not true because it's to a great degree it's about technology as well. The second one was that you can throw any technology and they will work. It's not true. You need to have this specialized technology. And the third one, that if you automate existing technologies, they'll give you DevSecOps. That is not true. If you automate imperfect technology, it would not give you perfect DevSecOps. So for example, if you automate invocation of your traditional static analysis that you run once in several months, yeah, you'll get some benefit, that tiny. The real advantage of automation is that when you automate it through the use of your developer and team test, when people run testing hundreds and hundreds of times. So be careful when you hear that automation is that what makes DevSecOps. I had a few slides on what future holds for application security, but I'll use them probably post-mortem if we have time for questions. I address some issues on future of static analysis, dynamic analysis, open source, software composition analysis, REST future, and so on. I want to move to conclusion. The first important thing that I believe we have to do is to come to particular realizations. And here they are. We have to realize that DevSecOps is not just about culture. To a huge degree, it is about technology. But not every technology is a perfect fit for DevSecOps. And we must have developed, acquired technology specialized to work with DevSecOps. And automation is not what makes DevSecOps. Automating imperfect technologies will not make perfect DevSecOps. You need to automate the right technologies, those that have been specifically designed for DevSecOps. We should keep realizing that DevOps requires incremental continuous, instantaneous, and transparent static security. Security should not distract DevOps from doing DevOps. That's the most important. The only way they adopt DevSecOps is when security is not preventing them from doing development and operations. So the only security that will work is security that DevOps doesn't have to see, doesn't have to learn, and doesn't have to run. So a few recommendations here. First of all, adoption. We should start as enterprises. We should start adoption with a traditional, unfortunately, technologies, because currently we almost have nothing. We should start using traditional statics, traditional dynamic, traditional SCA technologies, because they are fundamental technologies and they're also evolving towards DevSecOps. And we have to use services because they're better than tools suit new paradigm of DevOps and cloud computing. We should continue our process of adoption with adopting new transformed technologies such as developer desk and team desk. We should evaluate new technologies such as IaaS and REST, and we should apply new and transform and traditional technologies all together, but at right places of the life cycle. And we should keep watching market because it would be coming with new opportunities. And here they are. That's what is coming to the market. I really believe that we are entering the new era of application security. It's not security where there are only two technologies, static and dynamic testing. New generations of technologies is coming, technologies that offer new paradigms, application self-testing, application self-diagnostics, application self-protection, developer desks, developer sets, team desks. These are technologies that are coming to the market. And new markets are evolving with the new demands, such as demand for transparency that didn't exist before, demand for speed, for incremental and continuous implementation of these technologies. New paradigms are coming, cloud and DevOps, and they are so closely associated. By the way, that's one of the reasons why I'm saying that whenever you have a chance to use services versus tools, use services because they perfectly fit the cloud model that we use today from Google, Microsoft, or of course, AWS. There are new competitors coming to the market. Those that we previously ignored or simply didn't notice. I believe that in several years, open source will offer a quite formidable competitor to commercial vendors. And there are vendors, I call them GoogZone, which stands for Google and Amazon and Microsoft. Those cloud providers will be coming with their own application security solutions. So we have to build, plan, and adopt new technologies, new marketing messages, and new best sales practices. The only thing I can say now is I wish to welcome all of us to a troubling and exciting new era of application security. I'm sure it will be exciting. I'm sure it will be troubling. The only good thing is that altogether we can make it happen. Thank you very much for your attention.